Good morning. Today we will do a practical on micrometry of cell types. This practical comes in paper 8 for the final year zoology students. So micrometry is a technique used in biology to measure the size of microorganisms. Microorganisms, as you all know, are microscopic in nature and cannot be seen by naked eye. So the scales what we have millimeter and centimeter graduations or markings. These scales cannot be used to measure a microorganism. So how do we then measure the length, breadth, width or any other parameters of an organism which we cannot see through the naked eye? So that technique is called as micrometry. So the aim of this practical is to measure the size of a microscopic structure or a cell using micrometer. For this, we require two very specific scales. One is called as stage micrometer and the other is ocular micrometer. Ocular micrometer is also called as a eyepiece graticule because we insert it into the eyepiece and observe the specimen. Then we need a compound microscope and obviously a slide with a microorganism on it, which we are going to measure. Stage micrometer. Stage micrometer is a scale. So this is just like a micro slide what you see or what you place under the microscope, same thing, with a small marking here. Okay, the scale is present exactly at the center of this slide. The scale has divisions from 0 to 100. It is divided into 100 small equal divisions and 10 large divisions. Okay. Now this division, that is it from 0 to 100, is exactly 1 millimeter. So this scale is 1 millimeter scale divided into 100 equal divisions. Okay. So it's a glass slide and at the center is a graduated scale measuring 1 millimeter. 1 millimeter is made up of 1000 micrometers or 1000 microns. So this here the scale is divided into 10 large and 100 small equally placed division. That means one small division is equal to 100 micrometers. So you have 100 divisions, 100 into 10 gives you 1000 and that is 1 millimeter. So one small division in a stage micrometer measures 10 microns. This is a known measurement. It does not change. The second requirement is a ocular micrometer. Ocular micrometer is a disc-shaped structure with a graduated scale at the center. We insert or introduce this into the eyepiece or the ocular of a microscope. When you insert it and see through the eyepiece, this is how you see the scale. This also is divided into 100 equal divisions. So a graduated scale, one centimeter circular disc divided into 100 divisions. It can be placed inside the eyepiece. That is why you call it as eyepiece reticule also, or ocular. Eyepiece is also called as a ocular of the microscope. Now the distance between the divisions, this is what we have to see. The distance between the divisions varies with the objective of the microscope used. That means the distance between two divisions of an ocular changes with the microscope and the objective of the microscope that you are going to use. So this is an unknown measurement. This is how you have to insert the ocular. This is a figure of a microscope. This is called ocular or the eyepiece. These components are called as objective. You would have seen different magnifications, 10x, 45x, 100x written on it. These are called as the objectives. This is the stage. This platform is the stage where we generally keep a slide. And these are the adjustments, the coarse adjustments. Usually fine adjustment will be on top or along with this. Okay. Now here is where we place the ocular. So slowly we have to open the rim of this eyepiece like this, okay, and then insert the ocular micrometer into that and close it and observe. Stage micrometer will be placed on the stage itself. So this ocular micrometer, the divisions, the distance between the successive divisions of an ocular keeps changing with the objective of the microscope. So first thing here we have to do is to find out what is the distance between two divisions, because that is an unknown factor. So in the procedure is divided into two parts. One is called calibration and one is called calculation. So first we have to calibrate, that is calibration of ocular micrometer, meaning determination of the distance between the two divisions of ocular micrometer. What is the distance? That is what we have to first find out. That is called as calibration of the ocular micrometer. For this, we require the stage micrometer. Stage micrometer, as we have seen, is a known measurement. It's a 1 millimeter scale divided into 100 equal divisions, and one division measures to 10 microns. First thing is you have to place the stage micrometer on the stage of the microscope under the low power objective. And same way you have to place the ocular micrometer in the eyepiece, like how I have showed you. Now here, once you place the stage micrometer on the stage, you have to adjust the coarse adjustment and the fine adjustment knob so that you can see the scale on the stage very clearly through the eyepiece. Okay. Once you set this, then you should not touch either the adjustments or the stage micrometer. You should not move it. If you move, then it will go out of focus. So once it is set, then you can only move this eyepiece. Okay. What you have to do is, once you set the stage micrometer and you are able to clearly see the scale, you have to rotate the eyepiece, because ocular is placed in the eyepiece. This you have to rotate slowly, and then the scale of the ocular will get superimposed on the ocular division. I'll show you another slide. When you put both ocular micrometer into the eyepiece, as well as stage on the stage of the stage micrometer on the stage, and observe through the eyepiece, this is how you will see. You can see the ocular scale and you can see the stage micrometer also. Now, as you rotate the eyepiece, this scale will come closer to the stage, because as I told you, you should not touch the stage micrometer because it will go out of focus, right? So you have to rotate the eyepiece and bring this ocular scale closer to the stage. Okay, so that is what it is given here. Slowly rotate the eyepiece to superimpose or bring it very close the ocular micrometer division over those of the stage micrometer. Once you do that, okay, so here in this you can see the ocular micrometer, the smaller one, and the larger and the darker one, the darker lines and the large one, this is the stage micrometer. This is the ocular micrometer. Okay, now you have to rotate it, and any one line of the ocular should come exactly on top of a stage micrometer measurement. That is called coinciding lines. A line of the ocular micrometer should coincide with one line, any line. It doesn't matter. You don't have to start with 0, 1 or anything like that. Okay, it should coincide. Now in this diagram, you can see this 50. Okay, the mark 50 of the stage microscope is exactly below the point 1, the mark 1 on the ocular. You can't see mark 1 here. You can see 0, 2, 3, 4, 5. You can't see 1 here because this line, okay, 50 is on the mark 1. So this is called as a coinciding line, or you can say 1 of ocular is exactly on top of 50 of the micrometer. Once you find a line which is coinciding, then slowly move towards your right till you find another line which is coinciding like this. Okay. Now here the smaller lines are difficult for us to find out. We can see the larger lines. 2 is not coinciding, 3 is not coinciding, 4 is not, 5 is slightly coinciding but not exactly, 6 is not, 7 is not, 8 is not. When you come to 9, again you can see it is exactly coinciding with one line on the stage micrometer. So we have one line of coincidence here on 50 and another line here. This comes as 68. So let's count the stage micrometer divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is the line. Okay. So between one line of coincidence and second line of coincidence, there are 18 micrometer divisions. How many ocular micrometer divisions are there in the same distance? So here this is 1, this 2. That means there are 10 divisions. 10, 20, 30, 40, 50, 60, 70 and 80. Okay. This is the second line of coincidence. So between the two lines of coincidence, we have 18 divisions of stage micrometer and 80 divisions of ocular micrometer. The 50 mark, the same thing, explanation. The mark 50 of the stage is lined with 1 on the ocular. Work towards the right till another coinciding line is seen. The 68 mark of stage is lined with the 9 mark. If you want to go back, you can again see 50 coinciding with 1, 68 coinciding with 9. Okay. That means 80 small eyepiece ocular division, we call it as OMD, is equal to 18 stage micrometer divisions, right? Now, this measurement is a known measurement. That is 1 micrometer division is 10 micrometers. Okay? Between the two lines on one stage micrometer, the distance is 10 microns, which we have learned is a known factor. So 18 stage micrometer divisions occupy a distance of 18 into 10, 180 micrometer. So this distance between 50 and this is 68. Okay, this is 69, 70. So 68. Between 50 and 68 is occupied by 18 divisions. Each division is 10 micrometer. So it is 18 into 10. You have 180 micrometer. Now, in this 180 micrometer, we have 80 ocular divisions, right? 80 ocular division is equal to 180 micrometer. That means what is one ocular division, or what is the distance between two consecutive lines on an ocular? That's 180 divided by 80. It is 2.25 micrometer. In the microscope, what we are using, the ocular division is calibrated as, that is, the distance between two ocular divisions is 2.25 micrometer. The second part is calculation. So now we have found out what is the distance between two lines on an ocular. The second part is, now we have to measure the size of a microorganisms which we want to. You have to remove the stage micrometer. So stage micrometer is used only to calibrate the ocular. What we are going to observe is through the ocular micrometer. So we have to remove the stage micrometer and place the specimen slide, okay, on the stage of the microscope. Adjust the coarse and the fine adjustment so that you can see it very clearly. Now count the divisions occupied by the microorganisms. So here you can see, and here also it is not necessary that it has to start from 0, it has to start from 10, nothing like that. Okay, now you just have to see this is paramecium, which is focused here. Now this starts somewhere around 8, not 10, somewhere around 8, and goes up to 85. Okay, So paramecium is occupying from ocular division 8 to ocular division 85. So this is extending from 8 to 85 units. That means it is occupying a space of 77 eyepiece units. 85 minus 8, 77. So from here to here you have 75 eyepiece, sorry, 77 eyepiece units. Okay. Each ocular division we have calibrated as 2.25 micrometer. Now how much will be 77 then? That is, length of the specimen is 77 into 1 ocular division, that is 2.25, which gives you 173.25 micrometer. That is the length of the paramecium that we are seeing here. It is 173.25 micrometer. So first thing we have to calibrate, or rather we have to find out what is a ocular division. Okay, so this is the calibrated value. For this we have to use the stage microscope. After the calibration, remove the stage micrometer, place the specimen, see how many divisions are occupied by the specimen, and then multiply it by the calibrated factor. So here 77 eyepiece units are occupied by paramecium. So 77 into 2.25, that is 173.25, is the micrometer, is the length of the paramecium. So this is a technique used to measure the size of a microorganism, or rather micrometry. Thank you.